This is our day 10. And right here, we're going to basically walk through the wish list app or web frontend. So the smart contract we actually wrote previously, that is last week on Friday. That is what we're going to walk through. It's smart contract. Sorry, it's frontend. Okay. So let's just take this away. Now, maybe as that loads, let me just head on to my browser. Now we're going to search for near, or just we're going to search for near docs. Near docs. So let me just click on welcome to near documentation of the main page of the documentations of the near documentation, that is. And right here, let's have a look at should be tutorials, and that is going to bring us over here. Let me see if we can have it's not under tutorials. Great, right here I have web frontend, so that is under develop. On your sidebar you have this particular link. So this is basically going to talk about more about how you can interact with your smart contract using JavaScript, in this case from a web frontend, or giving a web frontend to your smart contract. Okay, so over here it gives you a full description on how you basically can invoke various things from JavaScript, or you can invoke various transactions from your JavaScript. And let me just see if I can find some important information I want us to have a look at. So, okay, so we have Node and HTML, good. So guys, again, maybe just to mention before we proceed, there's some, let me call it facelift or improvement that are being done to the near documentation or the near site. So if you find that whatever we're doing right now is not what you're going to sort of come across in some time to come, could be in a week or a month or so, don't panic. They're just trying to reorganize the pages or the content in this case. So there should be no cause of alarm. Okay, great. So at this point, I want us to, let's first of all talk about the web frontend. Now, if you're coming from other blockchain programming backgrounds like Ethereum, then you'll realize that they provide their own JavaScript library that you can basically use to interact with your blockchain, right? Then in NIA, there's also another library that has been availed, and that is what we refer to as, or we call NIA API JS. Now, for the better part of this course, we're going to use this particular library, NIA API JS, to invoke transactions to our smart contract that we deployed to the testnet previously. Okay, that is our wish list smart contract. And we're basically going to see how we're going to, first of all, configure the communication between our web frontend and our smart contract. Then from there, how we can sign transactions, how we can invoke various functions of our smart contract, okay? And basically how we can interact intuitively with the blockchain from a web frontend perspective. Now, let me just share this link in the chat. Maybe this is going to sort of give us more information. You can just find your own time, guys, and read through that. It's very helpful. Now, right here, yeah, you can. We told that we need to add the NIA API JS library to our code or to our web frontend project. Now, if you're coming from a Node, or if you're using this in a Node environment, the likes of React framework, Angular, Vue, JS, and all that, this is how you basically install it within your project. So you do npm install NIA API JS, okay? But whatever we're going to cover today is basically going to be, like the name has suggested, a simple web frontend. So this is basically going to deal with the HTML, the simple HTML you know about, okay? So we have these page.html, the other page.html. We have our JavaScript files over here, and this is how they interact. So that is basically the project we're going to walk through in this session. And so I'll really not focus on the node bit of this particular documentation, but I'll head on to the HTML bit of it. Now, if you head on to, or if you click on the HTML tab, you realize that you are given a link we can use to basically interact, okay, with that particular library. So it has been availed through as a CDN file, right, over there. And here is basically the library we are bringing in. So we are doing near API JS, and we bring in a minified version of that file, and all the security, all these are security, I think, credentials and all that, basically to authenticate credibility of the file you're importing within your project. So if you're working from an HTML point of view, then you need to copy this to your HTML file. Again, I'll be doing that. I'll be showing us how I've gone about that. And you're going to basically see how all these are going to unravel, okay? Now, with that in mind, maybe you can just have a look at how all these are being put in place, but I'm going to walk us through all that as we proceed. Then guys, as you can see, this is the project we are going to use, and I've not yet opened any file. So from what you can see in my on my sidebar is a CSS folder, a fonts directory, and a JS directory as well. Then I have 3 HTML files, the auth.html, the index.html, and new.html. Now, even before we go ahead and basically talk about how we're going to make transactions, right, with our smart contract in this case, I just want us to walk or have a, have a feel of what is basically, of what our app is basically going to do. Okay, so I'll just go ahead and open this app as a live server locally within my machine, that is. So it started on port 5500, and it has just fired up in my browser. So I'll just share this as well with us. I really hope you can now see my browser. I already tested this before. That's why you can see that it's giving me my information. So I'll just go ahead and log out. Now, if you are visiting this site for the first time, this is the screen or the page that should welcome you. So I just want us to first of all interact with our application and basically see what it's actually trying to achieve. Okay. Now I'll go ahead and hit on the login. So the login is basically going to link our wallet address, in this case, the testnet wallet address, to our application. So this way we are able to sign transactions on this particular application using our wallet address. So I'll just hit on login. Then this should direct us to our testnet dashboard over here. So you realize that that just directed me to this page. I'm going to select my account, in this case, do.testnet, and then hit on next. Then the whatever permissions that is required will be listed over there. You read through that, and you just hit on connect. So this is basically going to link your wallet address to this particular application, so that you're able to send transactions using that particular wallet address within this application. Okay, so that is basically what's happening over here. Like I said, I already tried it, and that's why you can see there's a record over here of a car I just added to a car wish list. All right, but I'm gonna go ahead and delete this for now. So by deleting these, we're basically testing our remove functionality of our smart contract. If you can remember that actually from our previous week's class. So I just hit on the delete. It took quite some time before it disappeared. Again, I'll be explaining why that was the case, so don't be worried. Over here in green, it is listing or basically showing the wallet address that has logged in this case, do.testnet. Okay, so I'll just go ahead and hit on the new button, which is directing us to the new.html page over there. Then over here, I'm going to select or key in my car information or the car information I want to add to my wish list in this case. So this is the link to the image. Let's give it a name, in this case, Toyota. Model should be RAV4. Mileage, give it anything. And the year, give it some price. Then let's just click on add. So the moment I click on add, you realize it is going to direct me again to my wallet. I hope you can see this, guys. It has just directed me to my wallet again, and it is saying that, hey, you need to approve transaction, and here is the transaction. My smart contract is trying to request usage of one NIA token from your wallet address. If I accept, I'll approve. If I don't, I'll simply cancel. So let's go ahead and approve and see what's basically going to happen. So once I approve, it will send the NIA token specified, in this case, one NIA, to the smart contract. And after sending that, the smart contract will proceed to process what? The transaction. Now, if we just head back, I'll just hit on the back button. Now, if we head back, if that record or if we attached enough NIA token to our transaction, then the record was added to our smart contract storage, or that data was persisted in our wish list record. And now coming back to our dashboard, in this case, the car wish list dashboard, it lists that car as a record down here. And I really hope you can see that as well, guys. It has just listed the car we just added down here. Now, I can go ahead and delete this car just as we saw previously. That is actually the first thing I think I did after logging in. So I simply clicked on this icon and it deleted. But you realize that it took some time. So it sort of delayed, right? Before it actually reflected the change on our interface. So that is brought about by the async await processes, or let me call it the asynchronous processes within our web frontend, okay? Because the transactions you're going to invoke are going to be asynchronous. So we're basically going to have them in we're going to sort of enclose them in a promise, in an asynchronous transactions. So this is the way we are able to get their responses later, okay, and not immediately. That's why there was some sort of delay. So in a nutshell, that is basically how our smart contract is going to behave, or how we're going to interact with our smart contract, okay? Maybe just something you need to note before I proceed. I'll just log out to show us this, guys. If I log in again, I hope you remember the wallet address where we deployed our smart contract previously. So that is what I want to show us right here. So if I click on next, I just clicked on the login button. It directed me here, and I now want to click on next. If you're keen, you realize that it lists the contract that is trying to request for this particular access. Okay, so in this case, it is saying, hey, there's a smart contract deployed on the NIA protocol blockchain at this address, so wishlist.c4sanctuary.testnet, that is trying to request for this permission for various interaction or transactions on it using this particular wallet address. Okay, so if you authorize that, it will basically link the two. So that's why we are able to sign certain transactions. Now, I think that is basically it. So that brought me here again, and it is going to take some time before it can list that record. Great. So that basically happens. So this record is basically coming from blockchain. Okay. Now I'll head back to our, let's head back to this VS Code window. I really hope you can now see that quite clear. Sorry. Now I'll really not walk us through The auth.html is the authentication page where you're requested to log in. New.html is the page where we are adding a new car record and submitting it to the blockchain. Index is where we have our wish list car records displayed to us. It sort of it acts as our dashboard. Okay, so I'll really not walk us through all these HTML guys. I think we are familiar with these. And again, I'm going to share this in a GitHub repository, so you don't have to worry about that. The CSSs are normal. I'm using Bootstrap in this case. Then the fonts, again, I won't walk us through that. So our main concentration in this case is going to be in the JS file. And in particular, the config.js file, the index.js file, and utils.js file. So again, we won't look at the Bootstrap stuff. But just something I wanted to note in these HTML files is the importation of our near API.js library. So here we go. So here it is, okay? So right here, you realize that we are bringing it in right here, basically through the link I showed us previously while I was sharing the browser window. So we are bringing it in as a CDN through a CDN. Then after that, we have, so it comes first, okay? Then we have our other JavaScript files following, right? So this is basically what is going to avail our near API.js objects or modules that we need to use, okay? You realize it appears in all the 3 HTML files. So really take key note of that. If you're working from a HTML, in a HTML project, then this is how you go about this. You need to ensure that the library is in place before you can make use of it. Then the JS files where you're going to make use of this particular library follows next. So you also need to consider the importation, the priority of your importation. So you realize that this comes first, then your local JavaScript files, okay? So if you are to bring this last, then it would cause some conflict. So really check good keynote of that. Now, let me walk us through config.js file. So I think this is where we can best start this particular discussion. Let's have a look at this file and basically have a look at its content. So we are having 2 variables, in this case, constant variables. So the first one in line 1 is the contract name. And the contract name is basically going to contain the address or the wallet address or the account ID where our smart contract lives. So I'll just comment this here, account ID, where the smart contract is deployed. Account ID where the wish list smart contract was deployed. So I hope that is now visible. Then the second one is the app name. So this is basically how we're going to name our app, okay? You can choose to add these or choose not to. This again, this one is optional, if I may say. Then we have a config function. So this is the function that is basically going to help us configure communication between our web frontend and the smart contract or the near protocol blockchain. So really take good key note on this. Inside this function, this is a JavaScript function again. Inside this function, we have a switch statement that is basically going to return some values based on a parameter we're going to pass as the env parameter. Now, if we pass anything as production or mainnet, any value matching any of these 2 cases, then you're going to return an object with all these information. So this particular JSON object, all right? This one basically gives the network ID. In this case, this is the mainnet. So you'd really use this case scenario if you're now moving to a mainnet, okay? So this is basically going to configure communication between your web frontend to a smart contract deployed on the mainnet. Now, for test purposes, however, like in our case, we're going to use development of test network values or case for us to be able to realize or to return this particular JSON object that we're going to use to configure communication between our web frontend and the smart contract we deployed on the test network, in this case, the test net. So this will give the remote procedure, the configuration or configuration of communication between our web frontend and the smart contract. And here all the information we need that JSON object to contain. Okay. Now you realize, let me just talk about something, let me just say something small about the Keystone attribute. The Keystone attribute specify where our keys, in this case, the access keys we're going to use to sign transactions between, or to sign transactions with this particular smart contract using our wallet addresses, where they're basically going to be stored, okay? Now, we have three ways you can store these access keys, okay? One is browser local storage. In this case, the access keys or the public keys that your app is going to generate to sign transactions, they are all going to be stored in your browser. So that's why we have the browser local storage keystone method we are using over there. So this is basically going to avail an object that is going to ensure that the keys are stored in your browser. There's also another method that allows you to implement the storage of keys in computer memory. So by computer memory, the values are not going to be persisted, or let me say, you'll have some sort of control over the storage of these particular keys, okay? But as it is, they'll be stored in the computer memory, okay? So we call it, I think we call it memory key store. I'll just get the name and maybe make the clarification. Then the last method is where you have these keys stored in your computer in form of the JSON files. Actually, what we went through while we were doing the near CLI, when you were interacting with our smart contracts from our near CLI. So you realize that the transactions you are signing, or the way we were specifying or signing transactions from our computer terminal, we are providing a certain flag, -- account ID, then specifying the wallet address. That basically, before that transaction was actually taken to blockchain, it was signed within our computer using the credentials that were stored. And I think I showed us that when you log in from your command line, that is, using near login command, okay? The credentials were basically stored locally within your machine. And so any transaction you'd sign, or we were signing from our terminal or command line, was making use of the credentials in those files, in those JSON files. Now, in this case, we're going to use browser local storage, and it is going to return this object because we're going to use a test network. And if something invalid was passed, then it will basically throw that error. So that is basically it about the config.js file. I'll now take us through the Utils.js file, and this is where the gist of our discussion is, I'd say, okay? Because this basically, here's where we're going to unravel most of the concepts and basically how to go about them. Now, the very first thing I'm doing in line 1 is getting the configuration object that is basically going to help us establish communication between our web frontend and our smart contract on the test network, near protocol, on the near protocol test network, okay? And I'm passing in development as a value, which is basically going to give us the test network configuration object. as I've highlighted over there. So we get that object and store it under near config variable. Then right here, I have an async. This function is basically going to be declared and invoked immediately. Now, if you are a JavaScript developer, I hope you are familiar with this. So this function is basically looking like this. Okay. So we have all our statements coming inside here. So I can have this in a new line. So we have all our statements coming inside here. So this function is, there's this function inside here that is basically, so this function is going to be captured inside this bracket, and we basically invoke it immediately. Okay, so we declare as we invoke. So I really hope this is not going to confuse us. Let me just undo all that for now. So that is basically what we are doing here. And this is the function where we're going to initialize or establish, right, communication between our web frontend and our smart contract on the test network of the near protocol blockchain. Now, let's now walk through the code. Take keen interest on every statement we're going to talk about. If you don't understand anything, just raise the concern. Now, in line 6 and or inside our initialization function, we are availing a near object or an object under a variable near. And this variable is basically being availed globally within our application. And that's where we are availing it as a window, as one of the window elements. So in this case, window object is global within our app, right? So we are attaching an attribute to our window object, and we are calling it near. And the near attribute is basically going to contain a value that will be returned after invoking the line I've just highlighted, part of that line, line 6 that I've just highlighted. Okay. So first of all, our initialization function is an asynchronous function. This means that we don't have to wait for it, or it is not going to block other executions within our program. Okay. So this basically, or this keyword is basically going to help us invoke other asynchronous operations within our function. And in this case, we are going to be able to await for their transaction, okay? Or do them in series. I don't know if I'm getting the idea across in the right way. So at this point, we're sort of going to block the transactions or the asynchronous transactions so that we force them to be executed in series, so one after the other. That is basically what I meant. Now, right here, the near API object that I'm making use of, I've just highlighted it. I hope you can see it, guys. This near API object that I've just highlighted is coming from the near API JS library that we just linked to our web project via the CDN link I showed us earlier. Now, through this object, we invoke the connect method or function of that particular object, passing in our configuration object we stored in line 1 under the near config variable. So this is basically going to give us an object that we're going to store under the variable near, under the attribute near of our window object. Then let's now move down to line 10. Here we are basically initializing wallet-based accounts, okay? It can work with near testnet wallets that are hosted through these links. So this is basically where that is where you create your testnet accounts, okay? So this is basically going to help us link our near wallets, right, to our project, our system. Now, again, right here, we have the wallet connection attribute we're attaching to the window object. And inside that wallet connection, we are going to store an object that is going to be generated by invoking that particular section of that line. So we're doing new, again, making use of the near API object, guys, that we brought in through the near API JS library. We invoke the wallet connection function, passing in the near object we created up here in line 6. So you remember the near attribute. So the value that was basically stored in this particular attribute is what we are doing, what we are passing down here for us to be able to create a wallet connection. Okay, so we have the network configuration info held in the near attribute of our window object. Using that network info is what, so that network info is what we are basically passing down here and is helping us establish a wallet connection to our project. Now, using that particular wallet connection, we are again going to get the account object. Now, that is in line 11, the account attribute of our window object is going to contain the account value or an account object. In this case, the account that is going to log into our application. Okay, so you realize when I clicked on the login button in our preview, in our wishlist project preview, it directed us to our wallet, our wallet addresses or dashboard. Then we authenticated the connection. Then it basically directed us back to our application. Now, after we basically authorized that particular connection, it came back with some information that are now going to be stored under this attribute account. So that is basically what this line is trying to help us establish. Let's move on to line 14. Now in line 14, again, we have the contract attribute of our window object. And this particular attribute is going to contain an object that is going to help us establish communication. Get it clear? Communication between our web frontend and our smart contract that we deployed on the test network. Okay, so the object in this contract attribute is what is what we're going to use to make transactions or to invoke to be able to interact with our smart contract. In this case, the smart contract we wrote in our previous session. Now let's see what it requires for this to be configured. Our smart contract is going to need the user to sign certain transactions, and it is going to need users to log in. So basically perform various transactions, okay? Now, right here, we're still making use of the near API object available to us through the near API JS library we brought in through the CDN. And we're invoking the contract function, passing in the following parameters. Now, if you can be keen, there are 3 parameters. But if you read through the documentation, there are some other optional parameters you can actually provide, okay? So I've not featured that right here for now. The very first parameter that is required or you're required to pass in is the account object. The account object is the account that is basically going to sign transactions in the smart contract. In this case, the wallet address that is going to log in or sign in to our app. That information is held in the account attribute. So that is basically what we are bringing inside here. And I think I can just pass in this explicitly as window.near. And right here, I also do window.near. Window.account, so that we eliminate any confusion that might arise. Then over here, I'm basically bringing in the contract name, right? I think we defined this in our config.js file up here, the contract name. So this is the wallet address. The wallet address where the smart contract was deployed to. Again, really take good note of that. So here you provide the wallet address where the smart contract your web frontend is going to interact with was deployed. Okay, that is what you provide over there. Then this other third parameter is a JSON object. Sorry, guys. This is a JSON object, and this object has the following attributes: the view method, the change method attribute, and the sender. Okay, so the view method attribute is basically going to contain an array of methods that does not require user to sign them. So methods that can be invoked without requiring the user to sign using their wallet addresses. So you can basically invoke them. So these are the view functions or the view methods in our smart contract, to put it in short. The change methods are methods within our smart contract that are going to require the user to sign. So in this case, you must attach your wallet address to them for the transaction to be successful. Okay. And if you can remember again in our smart contract or our smart contract source code, we had a function named add car. We had a function named read wishlist. We had a function named delete car. Now I'll just go ahead and remove the last one because that one is, we didn't have such a function. So we are having these three functions in our smart contract, in our wishlist smart contract source code. Take key note on the spelling. So the spelling must be as they appear in your smart contract source code. Must. If let's say in your source code it was add underscore car, then you decide to use the other convention in JavaScript and say, instead of add underscore car, you go for add the camel case, add car. So this is going to fail because you don't have a function within your smart contract with these function name. So this one is automatically going to fail. Okay, so the function names must appear in this particular array as they appear in your source code, in your smart contract source code. Take good note of that, guys. Otherwise, you're going to run into unnecessary errors. Now, the other attribute within this JSON object is the sender attribute, and this is basically going to contain the account object, right? Again, this is going to be window, just to have it explicit over there, window.account. Then we pass in the window object. Of course, the window is a global object, so we pass it in, and that is how we've been able to make use of it within our function. Okay, so that one, all that was just to configure the communication between our frontend and the smart contract. Okay, so we've really not done anything in terms of invoking, transactions to our smart contracts and all that. But that is what we're going to look at next. I don't know if I can just minimize that. Now, there are functions that are right here, but then they don't appear within our smart contract. So let me say these are functions that are basically going to help us establish, let me say they add some functionalities within our app that are required for us to make certain transactions within our application. You realize that we need to log in to our application before we can make any transaction or any interaction with our smart contract. Okay, because all the functions in our smart contract must be signed. They are all listed as change methods. So they must be signed. A wallet address must be attached to them for them to be successfully transacted. So how do we link our, or you realize that in our smart contract, we have no function like a login function that is going to basically help us establish the connection between our wallet and our smart contract in a web frontend, that is. Okay, so these are basically functions that are coming out of the box in the near API JS library that are going to help us establish all that or put all that in place for us to be able to proceed with our transaction. So the very first thing or the very first function we're going to look at is this is signed in. So if I can just provide a little documentation on this one is basically going to return a Boolean value. And it basically checks if the user is logged in or not. Okay. So it is basically checking if there's a wallet address linked to this particular application or not. So that is what our is signed in method is trying to achieve. And if you can be keen, we are making use of our wallet connection attribute that we just defined up here in line 10. So you remember this line where we are storing the wallet connection object. So we are making use of this wallet connection attribute down here, and we're invoking is signed in method or function out of that for us to be able to establish that information. Down here, we are still making use of this wallet connection attribute, but this time around we are invoking the get account ID method. So this method is basically going to return, or it is going to return with a value of the wallet address currently signed in to our application. Okay, so this is where we are going to get the actual wallet address that has signed into our application. Okay, so returns the wallet address linked to our app. Let me put it there. Great. So it basically returns the wallet address linked to our app. Then log in over here. Log in, again, we are using, so login is a function, guys. These are custom, so is logged in. These are just functions I'm making use within my application to help me organize these. But the actual functions you're going to invoke for you to get all these functionalities are going to come from the wallet connection object we just created in our configuration up there. So we've gone through the get account. So in login, the login function right here, again, that is a custom function. We are making use of, that is inside it, we're making use of the wallet connection attribute of our window object, and we're invoking the request sign in method. Now, while invoking this method, we provide the address of the smart contract requesting access. Okay, or maybe to put it in another way, you're going to specify the smart contract, right? The wallet address of the smart, where you deployed the smart contract, that is going to basically interact with this application or this web frontend, where you're going to make your transactions or where you're going to channel your transactions. Okay, so in our case, we have a smart contract deployed in wishlist.c4-sancore.testnet. So that is what you're basically passing right here, because that is a smart contract we're going to interact with in our web frontend. Then you can optionally pass the app name. This one is optional. Pass the app name, and that will basically be done. So you always want to run this function if and only if there's no wallet address linked to your wallet, to your app, or if no one has signed into your application. That is when you want to make this invocation. And that's why we are having the if function to first of all establish that there's no wallet address linked to this application currently. So we have the is logged in function, the usage of this function right there. So if we have a wallet address, if we don't have a wallet address logged in, this function is basically going to return false. Then we negate the false to be true, and we go ahead and make this call. Okay. However, if there's a wallet address that was actually linked to our application, then this function will give us true. And if we negate true, this will be false. So the final value will be false. And the if block, the else block will be executed. So it will basically display to us a message saying, hey, you're already logged in as, then you get the wallet address that is currently logged in to application. So that is basically what's happening right there, guys. Then now let's move on to the logout. So again, the login links, if I can just write this, links wallet address, links wallet address to the web frontend. Okay, that is basically what our login function is doing. Then our logout function over here, if we can just have this documented as well. Logout function is going to unlink. So you're logging out. We are basically deleting the access credentials you initially established, that was initially established between your wallet address or your wallet and our application. So this one is basically going to unlink or revoke that access using that particular public key that will be generated. So the very first thing we check is if the user is actually logged in or if there's a wallet address linked to application. If so, then we go ahead using the wallet connection attribute of our window object, invoke the sign out method. And the sign out method will basically perform the unlinking of the wallet address from our application. And so that particular access key will no longer be valid to sign transactions within our application. So this one unlinks wallet addresses. If I can just have this put here, unlinks wallet addresses from our application. Great. So once that is done, the page is going to reload or to refresh if that was done successfully. If not, then in this case, if the user was already logged out or if there's no wallet address that was initially linked to application, then it will basically display this message that, hey, already logged out. So there's no wallet address to unlink. Okay. So up to that point, those were just methods that are going to help us establish or achieve some added functionality within our application. Okay. Now let's shift our focus to our smart contract methods. Now, from here, we're going to see how we can basically interact with the functions that we wrote in our smart contract or our smart contract code. Okay, our smart contract code is basically the software that we deployed in blockchain. In this case, what we wrote using the Rust programming language, compiled it down to the WebAssembly bytecode, and deployed it to the MIA test network. So we're going to see how we can invoke those functions, but from a web front-end perspective, because we already saw how we could achieve that from command line point of view. Okay, so here or the functions we're going to go through now is what is going to help us establish all that. And I'll begin with the add car function of our smart contract. And again, just to reiterate, my add car, the add car with the camel case function is a custom name that I've just chosen to use within my web frontend. Okay. But the actual function that is going to be called, or the actual contract function we're going to call on our smart contract, is depicted with this other add car function name. So don't get confused on that. This one lives within our web frontend, but this one is going to be depicted, or this function is what lives in our smart contract. Okay. Then I'll just, I hope I've minimized all this because I'm going to make use of our configuration up here. to do the explanation. I don't know if I did that right. Yeah, this should be minimized. Good. Now, our add car function requires that the transaction be signed. In this case, our wallet address must sign this particular transaction for it to be successful. And so the user must log in to the application before making this call. And that's why in line 80, inside our add car function, we first check if the user is logged in. Okay? So if this is true, then we proceed with the transaction. Otherwise, we basically return a null value. Now, if that was true, then we proceed with the transaction and we invoke our add car function of our smart contract. Now, take a look at this. Again, this is coming from the window object, guys. So really don't forget that. So our contract attribute of our window object, this one is coming from our configuration up here. So the configuration was done in line 14. So this here is where we assigned the object to the contract attribute. Don't forget that. So we're going to make use of that particular attribute, the contract attribute of the window object, and invoke the add car function. So we do dot add underscore car function. So this is a function that lives in our smart contract. And before we can be able to invoke it right here, it has to be listed. Again, I'm going to take us back to the configuration. It has to be listed in either the view method array or the change methods array. So right here, you realize it is the first item we are having in the change methods array. So in these attributes, the view method and change methods, we are basically listing the function names as they appear in our smart contract as strings. Okay, so it's like we are listing, hey, we have a name in our smart contract that we have these function name in our smart contract, these are the function name in our smart contract, but then we provide all that as strings. That is what is listed up here. But when it comes to invoking the functions, we use the same spelling as they appear in the array, but then we don't provide them as strings. So in this case, we are using them as actual functions existing in our code. So that's why you realize that right here we are doing dot add car function of this contract of the object stored in these contract attribute. Okay, so we do window.contract. This one was initialized in our configuration function up there. Then we invoke the add car method out of that. And within this function, so this is the add car function existing in our smart contract. Here is how we provide its parameters. Okay, so there's add car, the normal brackets that comes in. So there is the first bracket and there is the last part of that bracket. So you provide the parameters of this add car function in a JSON object, and it comes as the first parameter to this add car function. Okay, as I've just highlighted over here, guys. I really hope you are able to see this. As I've just highlighted it over there. Now, our add car function of our wishlist smart contract required the image, or it had an image parameter of type string, the name parameter of type string, model was also of type string, mileage was an integer, year was of type string, and price was of type, it was also an integer. Yeah. So we are bringing in the values to these attributes through these, the camel case add car function parameters up here. So it means we are going to accept the values to these attributes as parameters of the function where these the whole of this transaction is taking place. Okay, so I'm having all these transactions enclosed in this add car function. And this add car function is going to accept parameters as captured up there. So these parameters are what we're going to pass down to our add car function of our smart contract as arguments. So that is basically what we are trying to do right there, guys. I really hope I'm not confusing anyone. Now then, after the JSON parameter to this add car function, there are some other parameters that we explicitly never listed or captured within our add car function in our source code, in our smart contract source code. But then they are required to help us establish. Now, this one is a sort of blockchain specific, because for these particular transaction to take place, like I said before, we must attach some gas. Okay. So again, this is optional because we have default gas value that is going to be attached to any of these transactions by default, and that is 30 teragas. So that is what you are bringing in as the second parameter. Then the third parameter is the amount of near tokens we are going to use or we're going to attach to this transaction. So the third, and I think it is the last parameter to this add car function, this is the amount of near tokens we are attaching to this particular transaction, and it is coming in Yocto near. So this one has been availed in Yocto near. Okay, so it means 1 near is equivalent to 10 power 24 Yocto near. So these zeros are basically 24 in number, the zeros. Okay, these are, so it's 1 followed by 24 zeros. So this is what qualifies as 1 near token. That's why while we were adding a car to our wish list, it was directing us to a wallet address, and it was listing there 1 near token required for this particular transaction. Again, I'll be showing us that as we proceed. So that is basically it about invoking our add car function. So this one is an asynchronous function. Take note of that. It is an asynchronous function. Okay. And so we're going to wait for it to sort of respond or give us some response before we can proceed processing it further. Now we have these keywords in JavaScript, async and await, that are basically going to help us enforce processing of these transactions in series or one after the other. So right here, we are forcing line 81 to be executed first before we can proceed to line 93. Okay, so that's why we have the await keywords used over there. So this one is basically going to await for the response from this function, and that response is going to be captured under the response variable, and this response variable, or the value in this response variable, is what we're going to return. We're going to have as the return value of our camel case add car function. Okay, I hope that is really clear, guys. Now let's move on to reading our wish list or getting the content of our wish list. Okay. Again, I'm having my own my custom function I'm using within my web content called read wish list in camel case. So within the read wish list, I first of all check if the user is logged in using the is logged in function we saw earlier. If this returns true, it means there's a wallet address linked to our app. And so I can go ahead and invoke the read wish list of our smart contract that we deployed on the test network. If not, then we're basically going to return an empty array as captured right here. Okay. So if there's actually a wallet address linked to our application, then we're going to use or make use of our contract attribute or the contract variable, if I may put it, just so that I don't confuse people. So the contract attribute is of a window object. So this one is available globally. We are invoking the read wish list function that again we captured up here. If I can just show this again right here. So we first of all listed it as a function in our smart contract under the change methods attribute of this JSON object. Okay, so once this was listed, it means we can now make use of it within, or invoke it through our contract attribute. And that's why right here we are doing contract.read wishlist. And then we are passing in the parameters. If you can remember well, guys, the read wishlist, read underscore wishlist function of our smart contract. Okay, so this function exists within our smart contract and it expected two parameters. That is the start and the limit. Take note of these, of the spelling of our parameters as well. Okay, the spelling of the variable names of our function parameters, they have to match. Otherwise, your code will, run into errors or bugs. So the read underscore wishlist function of our smart contract expected two parameters, and we are providing those parameters in a JSON object. So take good note of this. And this is what we are actually doing as well in the command line, right? We are providing the parameters, but in a JSON object. And that is what we also did with the add car function. They were all coming in a JSON object. So don't forget that. And within our JSON object, we have the start attribute and the limit attribute. And where these attributes are getting their values, the values are coming in as parameters to our read wishlist, our camel case read wishlist function right here. So the value the start value comes from here. So guys, I'd basically go ahead and do 0. I'm just giving us an example of what we did from our command line. So we'll specify that in our read wishlist function of our smart contract, give the start parameter the value 0 and the limit parameter the value 10. So this is basically how we will do what? How we would hard code this within our code. But then since we are capturing it as parameters through the read wishlist function, then we would as well come here and say, for our start parameter, give it the start value coming, or the value coming in under the start parameter, then the limit as well as limit. But you realize that this is going to be some sort of redundant, okay, in our JSON. So instead of, to do away with this redundancy, I'll just make use of, I'll just do away with one of these words so that I have start and limit. So that is basically how we do that. Again, this is going to cause an asynchronous execution. So we're going to basically wait for the response using this keyword, get the response and store it under this response variable. And in line 101, we basically return that response. Okay, great. So let's go ahead and try and delete a car. Let me just remove this function because we're going to make use of that. Now to delete car, again, to bring in some differences, I'll just name this delete car. Okay. So delete car function is also an asynchronous function like the rest, right? And inside here, we are also checking if the user is logged in or there's a wallet address actually linked to our application. If not, then we just return null down here. But if there's actually a wallet address linked to our application, then in line 108, we're going to invoke the delete car function in our smart contract. And we are passing in the ID parameter because our delete underscore car function of our smart contract required a parameter. The parameter was named ID, and that is basically what we are passing inside here. And the value is coming as a parameter in our delete car camel case function. So that is how that is captured. And we're going to again wait for the response and store the response inside the response variable, then return it as a value in line 109. Okay, so that is basically it about our utils.js file. So that's all that is going on. inside there, guys. Okay, and this is where all the interaction or invocations between our web front end and our smart contract is taking place. That's why I decided to, give more concentration or give more time in explaining this. If you have a question, just put up your hand. I'll be giving you that opportunity to, air it out. Maybe as we wait for that, let's take a look at what is happening in our index.js file. Okay, so in our index.js file, we are basically invoking the functions we've just declared in utils.js file. All right, so this is where we're going to, based on so we listen for the click events and do what the users instructed in the interface, capture the form values. So again, I won't really walk us through this because this is plain JavaScript. This is what we know as web front-end developers. For instance, in line 22, we are listening for a form on submit event. So if the user submits a new car information through the form I showed us earlier, we capture the details. So we capture the image link. They can have this, capture the email link that way. Then we basically store the value in this variable, and that applies to the rest of these parameters you need. Then using those parameters, we invoke our add car function. So back to my utils. Let me see. Here is the add car function. It requires all these parameters. So that is basically what we are doing in our add car while invoking our add car function, camel case, that is, in our index.js, and we pass all this information as required. Something to note, guys, and again, I think I've experienced some challenges with some people when it comes to this. Now, if you are accepting an integer in your smart contract source code or in your smart contract source code, okay, you have a function that accepts an integer. From your web frontend, you have to explicitly convert that value to an integer. And we do that using the number.parseInt method. Okay, so number is an object. I think this one is availed globally within JavaScript projects. Then you simply invoke the parseInt function, passing in the value that the user has passed. It could be through a form or some other interactions, but just ensure it is in integer form, not string. If you pass a string, that invocation is going to fail. Okay, the rest required a string type. That's why we are not doing the same thing or the same conversion to them, because these ones are coming in or are captured as strings, and so we just pass them as they are, as strings. But then the price and the mileage needs to be integer or of type integer. That's why they are doing what? They are being accepted as integers. So take really good note of that. And the rest are just page redirections and all that. So we have in line 64, we listen for a click event in our logout button. And if that is the case, we basically invoke the logout function as we saw in our utils.js file. Then right here, we are displaying the contents that have been that have been sent back to us after reading wishlist. Again, right here, after reading wishlist, we get the response. Remember, we are returning some response from this. Okay, so that response should be an array. That is what we store here. Then we process it further within our for loop, just to give it some DOM appearance. And all these is helping us put all that in place. Within these DOM representation, okay, the one I've just highlighted, we are doing quite a bunch of things, guys. And this is why we have our delete button. So I'll just try and find it. Let me see if I can find the on-click event right here. Okay, So I have an on-click event in our delete button, in this case, the trash icon. And we on-click, we basically invoking the remove car function, passing in the ID, okay? And I think the remove car is somewhere right here. So here is the remove car, but we can just do away with this because you already have these somewhere as well. So we can just make this change quite quick. Back to our delete car, all these were successful. Instead of returning that, let's just go ahead and reload the page, okay? So that should be able, it's an asynchronous function, yes. So that should work quite beautifully here. We just go ahead and comment all that out. Now, we've gone through all that, okay? And at least we now have a glimpse of what's going on under the hood. So we have, we've had a look at how the events are unraveling in our web front end. So I'm going to basically rerun or take us back to our project. So I'm going to invoke this again. Let me just share the browser. We were here. So this is where we were. I'll give it a refresh and maybe just log out to start off. Right, so we are here. Okay. So I'm going to hit on the login button. And while I hit on this, I hope you remember what's going on behind the scenes. What function is being invoked? It is now redirecting us to our wallet address. And right here, it is requesting for permission. This time around, I'm going to select a different wallet address. Let me use polotieno.testnet. Then I'm just going to click on next. The permissions have been listed over there. And it is saying that, hey, the site requesting for this permission is living in this address. Yeah, that is the URL of that website. And the smart contract is deployed in this wallet address as well. So all the information is available over there. I'll just go ahead and connect. So wait for that to connect. Then it will redirect us back to our application if all that was successful. Yeah, we are here. So this one just took me back to, it redirected us back to the dashboard. So this is our index.html. So this is serving as our dashboard, and you realize that the wallet address I just selected has been listed right here. Maybe if I can increase the font up to that point. So here's the wallet address that we just used to log in. We have our logout button over here. By now you know what this is doing. Then our new button as well. So our new button is basically going to, direct us to the new.html page where we're going to be able to key in the car details that you want to add to our car object. So that is what I just did. I just clicked on it. It brought us to this particular page. And in this page, I'm going to select a name that we're going to use. So give it a link, right? I don't know if I can have these work. Let me see. Oh, no. I don't know why it's misbehaving from my end. Okay. So let's just select any image here. This time around, I'll use the second one. Then let's give these Toyota as well. Model, widths, mileage. So I'll just go with the defaults that have been listed here. Great. So I'm going to click or hit on the add button. And this add button is going to invoke the add car function that we saw in our utils.js file. Okay. So the very first thing it is going to do, because I have to attach some near tokens to this particular transaction, it is going to direct me to my wallet address to authorize attaching of the near tokens. If I were not attaching the near tokens to this function, then this would just happen out of the box. I mean, it would just happen straightforward. But now that I have to attach the near tokens, it must direct me first to my wallet address, dashboard, authorize the attachment or authorize the attaching of the near tokens, then proceed with the transaction. Okay. So that's why you realize that the other functionalities like delete car and read wish list function of my smart contract, I'm not being redirected to my wallet address. But when it comes to the add car function, I have to be redirected. Why? Because I have to pay some near tokens to cater for the storage space that this data is basically going to occupy within my smart contract. So I'll go ahead and click on the add button. And by the time I do that, it will take some few moments, direct me here. So right here, it is telling me that, hey, do you want to approve the transaction of one near token from the wallet address paul.otieno.testnet? This is an estimate of 0.00001 near. If you click on more information, it will basically bring you to this page, and it is listing the contract, or in this case, the wallet address where your smart contract lives or was deployed. So this is the smart contract where the near token is going to be sent to. Okay. So right here, it is telling us that one near token is required to process this transaction. And this one near token is going to be taken from your wallet address for Otieno, and it is going to be sent to this smart contract wallet address, wishlist.c4-sankore. The function, there's a function existing in this particular smart contract under this wallet address, and it has the function add car. So this is basically the function that requires this particular attachment of the near token. And you click on that, you'll realize that all the arguments that our function requires has been listed as well over there. Okay. So again, I'll just get back over here and approve for that particular transaction. So this one is going to send one near token to our smart contract, and the transaction will be processed further. Then we are redirected back to our application right here. So I'll just hit on the back button. So once I hit on that back button, there's a function that is being executed in the background, accessing that information from our smart contract. And you know, here it has been listed. So we had this function actually, sorry, this image. The name was Toyota, we had bits. We specified the mileage as 1,000, year was 2000, the price was 30,000. So that is basically what has been listed to us here. So this information is coming from our smart contract, okay? This is coming from our smart contract. There's no SQL database to this. There's no Mongo or no SQL database to this. This has been extracted or retrieved from our smart contract storage or persisted data. So this was made successful by the help of our read wishlist function in our Utils.js file. Okay. It basically went, so that function is basically being executed the moment our index.html file loads. So if some data is going to be returned, then it will be displayed in our screen, as you can see. But if there's no data that was found after invoking the read wish list in our smart contract, then it will basically return to us what? An empty array. And since our array is empty, or there's no item to be displayed, then you realize that this particular portion will remain empty. Now, this can be customized for various user experience techniques. You know, when the data is loading, you want to display loading. When the data is loaded and nothing was found, you display some content or no content was found, something like that, and all that. So you can always elevate these to meet your needs or your market needs, all right? But for the demo purposes, we just have it as it is. Now, I'll just go ahead and add some other random. These ones are now random. Give it some random price. Give it a random year. Add that. Again, redirect us to our wallet address to approve the attachment. So right here, let me just have this load rate right here. So I'll just approve that attachment. So it will basically go ahead and make that particular transaction, then directly back. So if I click on the back button, and I now expect 2 items listed. Again, it is taking some time because all that is being run asynchronously. And now my second item is find an image. The name of our car is Banana, the model is Beats and all that. So these ones are just random. All right. Now, we want to test our delete car functionality. So in that case, I'm going to hit on this trash icon. And if you can remember, the trash icon had an on-click event, which was basically invoking our delete function. So I just clicked on it. It is taking quite some time. Okay, guys. So that is the function. You click on it. It is going to take some time to process that within our smart contract, again asynchronously. Then once the feedback, or once we get the feedback, it will basically reload the page and retrieve the contents again. So I don't know if that was successful. Maybe if I can just open up our console. So right here, it is telling me that, hey, the reference remove car is not defined. Oh, so I think I just provided the wrong function name. If I go back to my utils, redo it again. So in our utils.js file, we had this delete car function, all right? So I just went ahead to our index.js file to capture it in our click event, on click event of our trash icon, okay? So here it is. So instead of remove car, we are simply bringing in delete car function. So that is basically what I did right there. So let me share this again and give it a try this time round. So we are here, good. And I'm going to hit on this button. So once I click on that, it will go ahead and invoke that particular transaction in our smart contract asynchronously. If that was successful, it will reload the page and then retrieve the remaining items. And this time around, we realize it's only one in our smart contract. That's why we only have one car record listed right here. Okay, so that is basically it about web or giving a web front end to your smart contract.
I have a question.
Yeah.
You said that at some point you were attaching gas, and at some point we needed to just to near to for the storage.
Attach near.
What
Yeah.
is the difference between attaching the near and the gas that is attached? Maybe automatically, or you specify? Yeah, that one.
So in this case, I said that this parameter is optional, right? So it means that behind the scenes, there's a default gas value that is going to be attached to this transaction. Now, the default gas value is usually 30 teragas, okay? So a value of 30 teragas in near tokens is going to be automatically deducted from your wallet address to cater for the transaction or the gas fee of this particular transaction. However, from your test as a developer, you might have tested your functions and you realize that there are some other functions that need more or cost a lot when it comes to gas consumption. All right. So in your web frontend, you may want to explicitly specify the amount of gas required for that particular transaction. So like in this case, instead of 30, because 30 is the default, we may say we need 90 teragas attached to this particular transaction for this particular transaction to be successful. Okay, so it's like saying from point A to point B, using your car, you need 5 liters of gas for you to be able to move from point A to point B. But usually, or in normal occasions, moving from point A to point B requires something like 3 liters of gas. But since you have some loads within your car and there are some extra weight added, you'll need 5 liters of gas for you to move from point A to point B. So if you go with the default, it means your car is going to come to an halt before you get to point B or the destination B. So you need to explicitly add the 5 liters required of gas for you to move from point A to point B. So that is basically what is being captured here. So if this transaction, because this transaction is actually taking less than, the default gas price, so I can just do away with this parameter altogether. That is the gas fee, and just attach the near tokens. Okay, so but in this case, I think there would be conflict with the argument. So we have, remember initially we had 3 arguments, but now we have 2 arguments. So I think that a conflict will arise. That's why we are having it explicitly specified right there, the gas fee as the second argument, right? So you just specify the default gas fee, the 30 teragas. So this is 3 followed by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 zeros to form the 30 teragas I was talking about. Then the third parameter of that invocation is where you attach or you specify the near tokens you want to attach to this particular transaction. If let's say we never required any value, any attachment of the near token, so we don't require the user or the wallet address trying to invoke this particular function in our smart contract to attach any near token, like has been the case with these other function, the read wishlist function. So you realize we only providing the parameters, but we don't specify the gas and the near tokens to be attached. Okay, so we're basically doing away with the last 2 parameters right here. So like the case with the read wishlist function, it is going to make use of the default gas value, in this case the 30 teragas. So the default, it is going to make use of the default value. So that is basically going to be attached by default to it, but then it won't attach any near token to this particular transaction. And that's why you see it is quite simple. Same to the delete car function, just the parameters. We don't specify the gas and the attached near. I don't know if that explains it, Jerry.
Yeah, I've understood.
Okay, great.